Welcome to this particular V2 tutorial. My name is Thomas Heinrich and we from Glare like to show you how to use this amazing tool for Ventuz. In this tutorial I go through the different chapters here and explain how to use the system. We have prepared a detailed PDF document where you can find all the parameter descriptions. You can download it direct from the Ventuz store, and it's also part of the package we created for you. We developed two kinds of particle system for your needs, static and dynamic. Dynamic has some more additional parameters, and it's made for movements where the particles should not follow the emitter, like mouse movements or trail effects. Here are the additional parameters for the dynamic system. The position, here it's linked to the mouse position. The new batch type, you can define two different kind of. The new batch delay. The new batch delay stands for the time between two batches being fired. It's only used when new batch time is set to new batch delay, means here. In this section you can find three different kind of animation modes, like manual, loop and one-shot. In manual you have the option to adjust the timing. This can be animated in a timeline, like slow motion effects or forward and backward. The one-shot is bind to the nudge, like here. If I combine this with a touch function, like here, I apply the nudge to the touch button and click, you see we have a emitter effect. And always when I touch, you see the particles emit. And the last one is the loop section. Here you see it's always looping in a cycle. For one shot you can press reset and it resets to 0. In this section you can define from what kind of object your particles should emit, like a mesh, a box or a ellipsoid. In this case we emit from a mesh. Some parameters has no effect, like the dimensions, because it's fixed on the mesh. If you like to change the emitter, like I prepared here, this is on mesh and in this case it's on the box, and here you have now the access to the dimension in X, Y and Z, and also the other kind of mesh. You have also the option to define the thickness of the emitter, like here only on the outer side, in the inner side the same on the box, outer side, inner side. For the mesh it doesn't change. If you like to emit particles from your own mesh, you have to load a DDS file. This is only used when the type is set to mesh. Use the output of the Glare mesh suite that will convert your custom mesh. We will show this in another tutorial, how to convert your own mesh into a DDS file. Okay, now we come to an important part, how many particles you like to see on the screen. Sometimes it's not important to have 128,000 particles on screen, maybe you need only 10,000. In this case, choose the maximum of particles you like to emit. In this case, here. The maximum number of particles is really important to decrease the performance. Select a value as low as possible for your settings. The higher the value, the higher the impact on the performance, even if the number of actual used particles remains the same. So if you choose just 10,000 here, you go up to here, you have increased the performance. You see, I see only 10,000, but I load a file with 128k. So just go down to 10,000. If I increase the value, we see only 10,000 on the screen. And now we see the full number. Another important point is keep an eye on the performance. In this case, you have to define how many particles I like to see on the screen and how many vertices has my original mesh if I like to emit from mesh. In this case, this mesh has around 64k vertices. So if I go up to more than 64k, you will see something strange will happen. This is because we cannot indicate the vertices and then the particles come from the center. So keep in mind how many vertices your mesh has and then select here the right parameter for it. Here you can define how your particle should look like and fade on the screen. Like here you can define in the mode, you can define if I like to have it an alpha blend, additive, screen, sub, multiply and manual. In the alpha blend mode you have here these two options. In all of this kind you have this option, but they didn't affect. So you have to go to manual and then you can change how the alpha should behave and how they should to fade. And here again you can define how the color should, the alpha brightness should behave. So here you have a lot of options to define the style of your particles, like the blending. Also just check the manual, the blending section. Here you can read every parameter for all the special cases. Here you can define the brightness of your particle. The base brightness you can define here. It's good to fade them in or out. The maximum brightness a particle can have. So here in this case we are 400, we can go down. You see, you can combine them. And then you have the option to make it random. In this section here you can define the colors of the particles, like they should behave in the lifetime. Okay, the static option here, the color mode, is really important to change the kind of colors they should have over the lifetime. Static means they have only just one color over the whole lifetime. If I go here and check the lifetime, you see just one color. If I go to gradient, it's a bit different. They start and end with a different color. This means color 1 and color 2. Here I can define both colors. And then we have the random from gradient. This means it gets a different kind of color between those two values. Another mode is the ramp texture. Here you can load a texture file, a color texture file. Like we prepared for you a lot of different kind of textures. Like here you can load just a simple texture from start to end. And in this case you see how they behave over the lifetime. And you have to define a random. You can define the random again from the colors you load here in the texture section. Here you have some different kind of values for the ramp texture. Color end and start, where the color should end and start the ramp. You see it's a quite nice effect. If you play around with the values you get really nice effects. Again, check in the manual the color modes, and here everything is clearly written. It behaves nearly the same like the color section, but here you have only a value. Like again, when I start with static, we can define the alpha for the whole particles, the start and the end. If I go to gradient, we start with full visibility and then they fade off, or we fade them in and fade them off. Or we can define a random again. Another one is the RAM texture. We can load a color texture. Again here in alpha. This doesn't affect, just the RAM texture is now for the fading. And again, random ramp. If I load another one, color textures also work. They will convert it to grayscale. It's only black and white. Black means transparent, white means visible. And again, these values here are for the start at the end. So you can adjust a bit in the value, in the texture, you can adjust where the alpha should start and should end. In the timing section, you can define how the particles should fade in or fade out over the lifetime, how the speed is, how quick they are, how they should spawn, like they should spawn every second or every millisecond or over the whole lifetime, just like here in this case I think 10 is enough. And you can define how they should start in the time mode, like linear. They start really linear, they fly over the lifetime linear in the direction, or they should accelerate, like they start with 0 and end with the speed you defined, or they should slow down. The emitter curves define how the particle should emit, like if I make a spawn like 1 or just 1 second, you see they come linear out of the emitter. If I decrease, a lot of particles start at the end, and less comes over the lifetime. In the other direction, increase, less starts, more come at the end. And thin means they start with a curve and end with a curve, like less at the beginning and less at the end. In the middle, they are much more. Spawn delay means I like to spawn all at the beginning, 0 just one time. A lot of particles should come, and over the lifetime, when they die, the next one will emit. Here I can define how long the emitter should emit particles. Here you can define how long they should live. And in the other direction, I have to increase the value if they live longer, so I have increased the spawn delay value. And if I like to have a repeat, see, you have a lot of options just with these some parameters. Again, look in the documentation. Here you can see a lot of written stuff for all the parameters. What happens when I change the parameter. Keep in mind, just here in the timing mode, you can define the speed, the spawn delay, and how the particles should emit, how they should behave over the lifetime. Here you can define how they should fade in, or they should not fade in, and not should fade in. They just plopping in and plopping out, or they should fade really slow in and should fade really slow out. This is the overall. It's just added to the alpha fading. It's just another option to fade them smoothly in at the beginning, at the end. It's on top of the alpha fading. We go now to one shot, and if I nudge, see how they behave. And now I go to accelerate. See, they start slow and end fast. Again, slow down. It just depends what kind of mode you have. Slow down linear, accelerate. And repeats means, in this case, it makes no sense, But if you go to one shot and make it double, you see 2 times a particle emits. I go to repeat 3 times, nudge, then they come 3 times. Here you can define how the particle move from the emitter starting point. This depends how you define your emitter. If you make a bigger emitter like here, or just from a single point, or just a mesh, this doesn't matter what kind of emitter you choose. This is just the overall movement. So in this case we start from just a point in the center. Here we have just simple, the timings, everything is linear, it's really straightforward. We just concentrate on the movement parameters right now. So here the timing is constant, or can choose between constant and time. Time defines the movement is calculated using the value, depends on the time, which leads to a lot of dynamic movements. Constant, the values are used to calculate a constant position for each particle that doesn't change over the time. Other movements is applied, like gravity or initial force. Like here, if I change to constant, initial force, you see, they should move. If I let it to 0, it's complete different behavior. The initial force defines how they should start. And here the initial attenuation means that the particle stops over the time. Here we have some more variations. Velo theta and velo p effects, like to get more variation inside the movement. And here you can define in which direction the particle should fly. See here, this is like a circle. Now they fly in one direction, and here in this case they fly in the circle way. Velocity, of course, in random. You can define the strength of the velocity and more variations in the random. And here you can define a more rotation variation inside the particles. If I increase this, you see they flying inside a bit more round, like more random. Again, if I go to constant, if I go to 0, zero this out, see, they're still in place. Here you can see what happens if I change the parameters. Go back to timing. It's completely different. So here you can define how the particle should behave over the lifetime, how they fly around, stuff like this. If you have experience, you know each parameter, what happens if you change this parameter or the velocity. It looks a bit strange, but it's logical. And again, all the parameters are here defined on the movement. In the PDF you can read what they stand for. This is on top of the movement. If you have here some movements in your particles and you like to add some gravity in one direction, you see they are on top. Over the lifetime they get gravity in the direction you define, X, Y and Z. Here you can combine all these effects with the gravity on top. If you make more velocity, they have more impact on the gravity as well. So use the force straightforward, they should not stop. As well in constant mode, if I go back to thing, the gravity still works with the constant mode too. See here. And the rotation as well too, so more velocity. See, with the gravity you get more realistic dynamics inside your particle system. You can define how the particle should scale over lifetime and the initial scale and a bit of scale random. Here you can see if I change the scale random x, you see we have a random scaling of the particles. Same like scale x normal, it's not a random, it's just the main size. It's always like if I like to have it bigger scale x and scale y, you should combine this with the same parameter. Start scale means it should start with a size of 0, and the end scale means it should end with a scale of 8. This is linear. So if we choose linear, we start with 0, with 8. So we have here different options how they should behave with the scale over the lifetime. If I say accelerate, they start slowly and getting bigger at the end. So, and thin means this it's in the opposite direction. So you see it's linear over the lifetime. Thin, and this depends again when I make it 8 from beginning and 0 to the end. We have here they start big, getting slower, getting smaller and getting bigger again. Linear, thin, accelerate. So this depends what size you want to have from start to the end. Start scale 0, so they start with 0 and growing up. Or you should like to have this over the lifetime the same size, then leave it with the same parameters. Again, random, you can define random scale 5 by 5. You see you have bigger and smaller ones. If I increase the normal scale 11, what is the end scale? 2. So I have a lot of options to change the scale over the lifetime. More random in the size you can define. This depends on the texture you load. Like points, mostly you like to have these points really round. So you see, if I load another texture, like something like this, you get more variations inside. Or the smoke effect. See, now you can scale them a little bit different and it looks completely more random. Here you can rotate the particles from the beginning or make a random over the lifetime and stuff like this. In this case you see if I switch it off, all the particles has the same rotation value from beginning on. So now here I have the option to make a little bit more like a random in the angle. Or if I set this to 0 and I like to rotate only the particles, you have the option to rotate this as well here too. Sometimes it makes sense to make a mover on the rotation for the lifetime. If you say I like to have a rotation here, really slow rotation like a smoke effect, and make more variations in the random, you see the difference. Sometimes it looks really nice to make an automatic rotation on top of it. Here you can define what kind of texture you like to use. Normally you load here your texture, just in the normal case you use a simple circle texture, or you like to have maybe a variation like atlas texture, like here. In this case we have here A, B, C, D, just 4 different numbers. In this case you can define here 2 by 2, and now you see you have 4 different kind of particles. This means in your texture you can divide your texture like in 2 by 2 or 4 by 4, and here you should say it like it's just a single one or 2 by 2, and then you can load more variations inside your texture. You see, we prepared here some different kind of textures. And again, here you can define how it's divided. Another cool trick is to define a texture via render target. In this case, we use this to make 3D elements inside the texture. Here we use the texture again. We go on texture, we defined 4 different kind of cubes. Render this in a render target, put it in the texture value, and tada, we have here, you see the 4 different kind of cubes they are rotating around. So you can change this cube to a sphere, like whatever you like to have, and animate this. When I block them out, see, here is my sphere. Whatever you like to put it in, and you have 3D particles. Screen fading can be used to achieve a depth-based fading. So all particles very close or very far from the screen can be faded out. So here is an example. You see with and without. Here you can fade the particles depending on the screen position in and out. And you can see what happens to the performance as well. If I fade them earlier out, we have, let's see here, it's on and off. We save a lot of performance. The same from the depths. Go further. So here you have the option to fade them when they come close to the screen. See here the performance, it's a bit different. And again, you have more options to make the fall off, how long the fall off should be, or you like to have it more intense, you can decrease the value as well. Same here, or decrease. So here you have the option to say, in the distance I don't like to see particles, so I fade them off, or in the close to the camera I like to fade them off, so they don't get so big. Switch on and off so you see the difference. In this section you can define how the sorting is and the seed, and some writing. If you have some writing problems, sorting problems, just mark this and you will see how the particles behave. It's just an advanced option to sort the particles correctly in your scene. So here you see it's the seed. You can make a different kind of random. Okay, here you see the override testing. Here we override the render options. In this case I put an option here with wireframe or just points, and if I mark this as on, we see, it's too tiny, but here if you go to wireframes or solid, you can override these parameters as well too. And here again another option to sort the sorting. You see a bit of difference in the background. This depends on your scene and how you like to organize your scene. Okay, that's it for this tutorial. We hope you liked it, and we are very curious what you create with this great particle system. Load the presets, change the parameters for your needs, and create your own presentation out of it. Okay, goodbye.